Hey guys, Mr. McKinney here, just going over how to find the average value of a function. And this is going to involve integrals. So as long as f is integrable on an interval from a to b, then the average or mean value is given by this function. And integrable just means that you can find the area underneath the function. So it doesn't have to be continuous in order to be able to find an average value. You just have to be able to find the area. So for example, the step function is not continuous, but you could still find the area underneath the step function. So the step function is considered integrable. Don't worry too much about that. It's just part of the definition. So if you're trying to find the average value of a function, this is the formula we're going to use. So 1 over b minus a, where a and b are the upper and lower limits. So 1 over b minus a times the integral from a to b of our function. Now this has to do with a theorem called the mean value theorem or the average value theorem for integrals. This is just a preview. So if the function is continuous in addition to being integrable, then you're guaranteed to hit the average value at some point. We're going to come back to this when we study theorems right before the AP exam, but I just wanted to put it on your radar for now. So for today, we're just focused on finding the average value. So I've got my formula, 1 over b minus a times the integral from a to b of f of x dx. And I want to find the average value for f of x equals x squared. And I want to go from 1 to 4. So this is my a and my b. So I have a and b, and then I have my function. So I'm just going to set up the formula and then do the work. Average value is going to be 1 over b minus a times the integral from a to b of f of x dx. All right, so I'm going to integrate this part. This type of problem would be on a non-calculator. If it was on the calculator, you could just hit math 9, but this is too easy to be on the calculator. So 1 over 3. When I integrate, I can use the fundamental theorem of calculus to figure out the area underneath this curve, since x squared cannot be found using a geometric shape. So if I integrate x squared, I'm going to get x cubed over 3. I don't write the integral symbol anymore because I already did the integral. So now I need to evaluate that going from 1 to 4. I'm going to go ahead and combine the 1/3 out front with the divide by 3 here, so I can just make it 1/9 x cubed going from 1 to 4. So I just plug in 4, plug in 1, and subtract, because that's what the fundamental theorem of calculus says to do. So 1/9 times 4 cubed minus 1/9 times 1 cubed. Let's go ahead and practice simplifying. So 1/9 times 64 minus 1/9. So that'd be 64/9 minus 1/9, which would be 63/9, which is better known as 7. So the average value for x squared between 1 and 4 is 7. Now let's think about what that means and see if it makes sense. So if I were to draw the graph of f of x equals x squared, and then I want to go from 1 to 4, the points that I would be having at my endpoints would be 1, 1, and then 4, 16. Now keep in mind that we're not just averaging 1 and 16. If I just average the two endpoints, I'm not going to get the right answer. 17 over 2 is not the same thing as 7. So you can't just average the two endpoints. You have to use the average value formula. And we're just trying to say, what is the average height of this function between 1 and 4? And it makes sense that it would be at 7. A 7 is a little bit lower than half between 1 and 16, and it grows more slowly at the start. So it makes sense that the average height would be less than halfway between the two endpoints in this case. You don't have to do any of this picture to find the answer. Just use the formula. I'm just trying to explain what's going on. All right, let's do one more example using Riemann sums. So I want to use a Riemann sum with a midpoint Riemann sum with 3 equal intervals to find the average value of f of x from 20 to 50. So again, the two endpoints of your interval are going to be a and b. A midpoint Riemann sum with 3 equal intervals. So we're going from 20 to 50. So 20 to 50 is 30. And then I divide that by 3 because we have 3 equal intervals. Each interval should be 10 watt. So my first interval is going to go from 20 to 30. My next interval is going to go from 30 to 40. And my final interval is going to go from 40 to 50. So those are my three intervals, 20 to 30, 30 to 40, 40 to 50. They're equal. Each interval has a width of 10. And since I'm doing a midpoint Riemann sum, I'm going to use the middle y value. So the midpoint of 20 and 30 is 25. I don't use 25, I use 38. Now remember, we're not averaging 42 and 31. That would be the trapezoid sum. We're just using the midpoint. So we're going to use 38 for the first interval. Between 30 and 40, we're going to be using the y value at x equals 35, which is 29. And then between 40 and 50, we're going to use the y value at 45, which is 48. All right, so let's set up the formula. 1 over 50 minus 20 times the integral from 20 to 50 of f of x dx. Now, since I don't have an equation, I can't find the exact value for the integral from 20 to 50 of f of x dx. So I'm going to use the method that they tell me. So in this case, a midpoint Riemann sum to figure out the value of this integral. So 1 over 50 minus 20 would be 1 over 30. And to find the value of this integral, I'm going to be doing a Riemann sum. Now remember, Riemann sums are either just adding up a bunch of rectangles or adding up a bunch of trapezoids. In this case, we're doing a bunch of rectangles. So for each rectangle, we're going to need a width, so between 20 and 30, and then a height, which we're going to use as our f of x value. That's going to be the height that we use, width and height, for our rectangles. So the first interval, we're going to get the width as 30 minus 20, so that's 10, and then times the height of 38. And then the next interval, we're going to do 40 minus 30 to get our width. Again, that's going to be 10. Now, it's easy to do 30 minus 20 and 40 minus 30 and 50 minus 40 in your head, but you want to make sure you're showing the AP reader how you're getting your answer. So go ahead and put 30 minus 20, even though you can do that in your head. Show them what you're doing. So 50 minus 40, and then the midpoint value I'm going to use over there is 48. Now, technically, on a free response exam, I could stop here. But we definitely need to be practicing simplifying. So 1 over 30, 10 times 38 is going to be 380. 10 times 29 is going to be 290. 10 times 48 is going to be 480. Whoops, 480. If I add all those up, I'm going to get 1,150 divided by 30, which is the same as 36.333. So the average value using the midpoint Riemann sum would be 36.333. You could also leave it as 1150 over 30, or really you could leave it as 1/30 times this whole thing. But we need to be practicing simplifying because this will likely show up on a multiple choice part of the exam. All right, so that's it. When you need to find average value, just use the average value formula. Side note, remember that if it ever asks for the average rate of change, you're just going to be doing a slope calculation. That's going back to derivatives. Hope this was helpful. Have a great day.